All right, your second page today for math is also kind of a logic puzzle like the other one. You've got an input and an output, and my mom, when she was a kid, she told me they called them function machines, where the idea is that you've got like a machine and something comes in and it does something and then it spits something out. And your job is to figure out like what's the machine doing with the number while it's inside of it. So you can imagine like they would draw like pictures of like machines. Like here's this machine and 3 is coming in and then it does something and then it spits out the number 21. Remember, like, what does the machine do with all these numbers to get out 21? And it's going to be doing the same thing with 3 and 4 and 5. Everything that happens in this column is going to be the same to get from the input to the output. So your job is to look at it and think, okay, well, how could I get from 3 to 21? What's that difference? And we're thinking, okay, let's see, 3 plus 18 is 21. But if I added 5 to 18, that wouldn't be 35. That's got to not be the pattern because they're not the same. So we're thinking, okay, well, maybe it's multiplication. 3 times 7 is 21. Does that work the same with this one? 5 times 7 equals 35? Well, that would work. So if that's the case, because the pattern has to work for the same all the way down, it can't be a different pattern for each of them. It must be times 7. 3 times 7, bother. Markers. Find something that works. Oh, I have one in my pocket. Times 7. So this is supposed to be 4 times 7. So 4 times 7 would be 28. 5 times 7 would be 35. That works. Now they're having us go the other direction. So times 7 here. What times 7 is 42? Well, with our math facts, we know it's got to be 6. And at the bottom, they don't even show us one, but we can figure based on the pattern going down, 3, 4, 5, 6, it's got to be 7 times 7. Their answer would be 49. You're just basically looking for patterns and then recognizing, oh wait, that's something that I've seen before. We can do one more here. We'll just draw our function machine. I used to hate that term as a kid, function machine. I think I'd rather have it just be called like a pattern. Input, output, and then our columns. And we can just, let's see, what would I want my pattern to be? Got it. Okay, so if I have, we'll start with 2, 3, and then I'll make this one and this one. Okay, we've got it. All right, so looking at this same type of idea here, you've got a function machine where the 2 is coming in, or whatever number, it's coming into the machine, it does something, there's some pattern it does, and then it comes out as 18. What's the difference, the change between the input and the output? And we've got a couple numbers here, so 2 to 18, well, but I know that 2 times 9 is 18, that would be an easy one. But would that work with the next ones down? Is 3 times 9 27? Well, yes it is. If you had originally thought, well, maybe I add 16 to it, 2 plus 16 is 18, well, that would work, but does it work with the next one? 3 plus 16 is only 19. That wouldn't work with our second number. That couldn't possibly be the pattern. So it's probably times 9, since that works with both of our numbers right here. Times 9, which would mean that this is times 9. 5 times 9 is 45. Notice I skipped this one because there's nothing here, because I can't figure out the pattern yet, 2, 3, but now I've got 2, 3, 5. What has to be here between 2, 3, and 5? Probably 4. So 4 times 9 would be 36. All right, so I hope that helps you figure out the ones for the day. I think they're a little bit easier than the other logic problem. I know that one might be a bit confusing, but I think you guys are all smart and can all figure it out. If you have any questions today, feel free to call or email. I'll be at school most of the day today, so hit me up if you've got any questions. Also, don't forget, we're picking up our stuff on Tuesday next week, so I need to know what time you're going to be here between 9 and 12 on the 26th.